Unit 6 Part 3. So first point is vehicle battery management system. The electrification in the vehicle electrified transportation is the most viable way to achieve a clean and efficient transportation that is crucial to sustainable development of the whole world. In the near future, the electric vehicles, including the hybrid electric vehicles, plug-in hybrid electric vehicles, and pure battery electric vehicles will dominate the clean vehicle market. By 2020, it is expected that more than half of the new vehicle sales will likely be use electric vehicles models. The key and the enabling technology to this revolutionary change is battery. The battery management system has some objective, that is protection and prevention of the system from damage, increase of battery life, maintenance of the battery system in accurate and reliable state, and battery management system, that is battery doctor. There are some key functions like communication, data acquisition, and balancing, like safety management, electrical management, and thermal management. Now, battery management functions are system checkup and SM power checkup. So it has four objectives: protection and prevention of the system from the damage, increase of battery life, maintain of the battery system in accurate and reliable state, and last is battery management system. Now, why need a battery management system in electric vehicles? The batteries used in electric vehicles should not be overcharged or over discharged to avoid damaging the battery, shortening the battery life, and causing the fire or explosions. The battery management system, that is BMS, with functions of the battery modeling, battery state estimation, battery balancing, etc., is one of the key points to protect the battery and optimize the utilization of the battery in electric vehicle. The electric car battery is an important role in electric car to keep going on the road. Thus, the electric car battery pack needs to be secure from the damage because of uneven temperature. Depending on the electrochemical used in battery, the optimum range is different, but the ideal optimum temperature of the electric car battery is 45 degrees Celsius in order to keep the performance and life for the battery. So this is a block diagram of battery management system. This block diagram consists of battery pack, battery management system, loads. In load, it consists of engine ECU, vehicle management and display, fans and pump. In battery pack and BMS, in between there is communication between the current, temperature, voltage and cell balancing. Now there are some other parts also, that is contactor, battery charging control, external charger or attenuator, DC converter. So there are battery management system keeps each cell within its that is temperature, current and voltage. These three are the main, the battery management system main function is its protection. So the protecting a single cell is hard enough, so protecting a battery is harder. Cell voltage do not divide equally, temperature vary. Its second function is balancing. All cells are equally charged, maximum available energy. The balancing removes the charge from fullest cells to leave from more charging, so the other cells can catch up. Now there are three types of battery management system: analog versus digital, off the shelf versus custom, and distributed versus non-distributed. So the factors which are used in the selection of energy storage device in electric vehicle. The system architecture of electric vehicle include mechanical structure, electrical and electronic transmission, which supplies the energy and information system to control the vehicle. The specific electric vehicle design considerations are listed, that is identifying and environmenting the market trend of electric vehicle, determining all the technical specification and estimation of load requirement of electric vehicle, assessing the infrastructure required for designing and also including the recycling of batteries, defining the system requirements according to its configuration for various applications such as hybrid electric vehicle, battery electric vehicle and fuel cell electric vehicle. Then fifth is defining its energy supply for different cases such as generation or storage, single or hybrid. Six is identifying the primary essential component of electric vehicle, propulsion system consisting of single or multiple motor, converter, transmission types and mounting methods. Seventh is determining its driving range and calculating specific parameter named as a speed, torque, energy and power density, etc. So these are the some specific electric vehicle design considerations. Now there are two types of factors that affect the adoption of electric vehicle, that is internal factor as well as external factor. Now internal factor, before that, a battery management system is an electronic regulator that monitor and control a charging and discharging of rechargeable batteries. It is simply a battery monitoring, keeping a check on the key operational parameter during the charging and discharging, such as voltage, current and the battery internal and ambient temperature. The monitoring circuit would normally provide input to protection devices which would generate alarms or disconnect the battery from the load or the charger should any of the parameter become out of the limit. The electrification in the vehicle is the most viable way to achieve a clean and efficient transportation that is crucial to sustainable development of the whole world. In near future, these electric vehicle including hybrid electric, plug-in hybrid and pure battery will dominate the clean vehicle market. So the electric vehicle are powered by a large number of battery cells requiring an effective battery management system to maintain the battery cell in an operational condition while providing the necessary power efficiency. Battery management system makes a decision on charge or discharge rates on the basis of load demand, cell voltage, current and temperature measurement and estimated battery SOC capacity and impedance. Now there are two types of the factor. That is internal factor and external factor. The internal factor, there are certain characteristics of an electric vehicle such as driving range, charging time and cost which make them less convenient in today's world. The electric vehicle are more expensive than conventional engine vehicles. Now, other major issues in adoption of electric vehicle is charging time. Although it is potentially less severe in comparison to driving range. Now, external factor means certain external factors may also affect the adoption of electric vehicle like consumer characteristic, fuel prices and the availability of charging stations. The hikes in the fuel prices are caused due to the burning of the fossil fuel in the combustion engine of vehicle. As the consumers have a different types of interest and the adoption of an electric vehicle depend on different consumer characteristics such as education, income, level of environment, number or type of the car owned and love for the technology. So the components of electric vehicles. The electric vehicles are based on the propulsion systems. No internal combustion engine is used. It is based on the electric power. So the main component of electric vehicle are motor, power electronic driver, energy storage system, charging system and DC-DC converter. So this is a diagram which consists of battery charger, battery inverter. Battery charger is connected to charge the battery, so it is connected to battery. Next is inverter, then motor, DC-DC converter, vehicle, computer and electronic. The most emerging transportation system, that is EV, is also described as an automobile vehicle that developed through the electronic system. Due to this, EV may include the HEV, BEV and PHEV. The use of the battery in EV, that is electric vehicle, has an absolute advantage over the traditional. So these are quite in operation, help in removal of the fuel gas pollutants which are created from the conventional vehicle, and the most crucial factor is exploitation cost of EV, which is 3 times lower. Unfortunately, batteries have certain disadvantages also, like substantial weight, the high cost of battery and volume impose significant range restrictions, and performance of battery changes according to the climate condition. Now, external charger is connected to the battery by the contactor and it is controlled by the battery control unit. Loads like ECU, engine and controller are connected to the battery by DC to DC converter to give the sufficient supply required to that by using a contactor. The BMS control the current, temperature and the voltage in each cell in battery. The basic electrochemical unit used to generate electric energy from stored chemical energy or to store the electric energy in the form of chemical energy. The cell consists of two electrodes in a container filled with an electrolyte. There are two or more cells connected in an appropriate series or parallel arrangement to obtain the required operating voltage and capacity for certain load. The term battery is also frequently used for the single cells. This terminology will be adopted in this terminology where a distinction between the cells and battery is needed. A good example is a battery pack which consists of several cells connected in series and or parallel. The different types of loads connected in a vehicle which are connected to the battery by direct connection or else by using a contactor and DC to DC converter as per their compatibility. ECU, motor, pump, fan, displays. The cell balancing is the method of compensating weaker cells by equalizing the charge on a cell in the chain to extend the overall battery life. In the chain of multi-cell batteries, small differences between the cells due to the production tolerance or the operating conditions tend to be magnified with each charge-discharge cycle. Now the electric drives. Now the system employed for a motion control are called as drives. It may employ any prime movers such as diesel or petrol engine, gas or steam turbine, steam engine, hydraulics motor and electric motors for supplying a mechanical energy for the motion control. The drives employing electric motors are called as electrical drives. So, whenever the term electric motor or the electrical generator is used, we have to think that the speed of rotation of these machines is totally controlled only by the applied voltage and the frequency of the source part. But the speed of rotation of an electrical machine can be controlled by implementing the concept of drive. The main advantage of this concept is that the motion control is easily optimized with the help of drive. In simple words, the system which controls the motion of the electric machine is called electrical drive. A typical drive system is assembled with an electric motor and a sophisticated control system that controls the rotation of the motor shaft. Now, this control can be done easily with the help of software nowadays. The drive system is widely used in the large number of industrial and domestic applications like factories, transportation system, textile mill, etc. The drives are employed as a prime movers for the diesel or the petrol engine, gas or the steam turbine. Now, the next is the parts of the electric drives, or we can say the block diagram of the electric drive. The first is the source, next power modulator, motor, load, control unit, sensing unit and input command. Now, the power modulator. The power modulator regulates the output power of the source and it controls the power from the source to the motor in such a manner that the motor transmits the speed torque characteristic required by the load. So it controls the power from the source to the motor in such a manner that the motor transmits the speed torque characteristic required by the load. Now, during the transit operations like starting, braking, and the speed reversing, the excessive current drawn from the source, and this excessive current drawn from the source may overload it or may cause a voltage drop. Hence, the power modulator restricts the source and the motor current. This modulator can be used to control the output power of the supply. The power controlling of the motor can be done in such a way that the electrical motor sends out the speed torque feature which is necessary with the load. During temporary operation, the extreme current will be drawn from the power source. The drawn current from the power source may excess it, otherwise it can cause a voltage drop. Therefore, the power modulator limit the motor current as well as source. The power modulator can change the energy based on the motor requirement. For instance, if the basis is direct current and an induction motor can be used, after that the power modulator changes the direct current into alternating current. Also, it chooses the motor's mode of operation like braking, otherwise motoring. The power modulator converts the energy according to the requirement of the motor. For example, if the source is DC and an induction motor is used, then the power modulator converts DC into AC. It also selects the mode of operation of the power, that is motoring or braking. Then power source. The power source offers the necessary energy for the system, and both the converter and the motor interfaces by the power source to provide the changeable voltage, frequency and current to the motor. Then load. The mechanical load can be decided by the environment of the industrial process, and the power source can be decided by an available source at the place. However, we can choose other electric component, namely electric motor, controller and converter. Then the next unit is control unit. The control unit control the power modulator which operate at a small voltage and power levels. The control unit also operate the power modulator as desired. It also generates the command for the protection of the power modulator and motor. An input command signal which adjusts the operating point of the drive from an input to the control unit. The control unit is mainly used to control the power modulator, and this modulator can operate at a power level as well as small voltage, and it also works the power modulator as preferred. This unit produces the rules for the safety of the motor as well as the power modulator. The input control signal regulates the drive's working point from input toward the control unit. Sensing unit. It senses the certain drive parameter like motor current and speed. It mainly requires either for the protection or for closed loop operation. The sensing unit in the diagram is used to sense the particular drive factors such as speed, motor and current, and this unit is mainly used for the operation of closed loop, otherwise protection. Next is motor. The electric motor intended for the specific application can be chosen by believing various features such as price, reaching the level of power and performance necessary by the load throughout the stable state as well as active components. Now there are some classification of electric drives. Usually these are classified into three types such as group drive, individual drive and multi-motor drive. Additionally, these drives are further categorized based on the different parameters which are discussed in that. First point is electrical drives are classified into two types based on supply, namely AC drives, DC drives. The drives can be classified into two types based on running speed, namely constant speed drives and changeable speed drives. It can also be classified into a based on number of motors, namely single motor drives and motor drives. And the last one is it is classified into based on the control parameters, namely stable torque drives and stable power drives. So the electrical drive is used for controlling the motion of an electrical machine, such a type of system is called electrical drive. In other words, we can say the drive which uses the electrical motor is called electrical drives. The electrical drives use any of the prime movers like the diesel or petrol engine like this, and these prime mover supplies the mechanical energy to the drive for the motion control. So next is advantages of electric drives. There are some advantages. The electrical drives are available in wide range of torque, speed and power. They are adaptable to the almost any operating conditions such as explosive and radioactive environment, submerged in liquid and vertical mounting and so on. The electrical drives does not pollute the environment. It can operate in all four quadrants of speed torque plane. The drive can easily be started and it does not require any refueling. So it can started instantly and can immediately be fully loaded, that is there is no need to refuel or warm up the motor. They are flexible control characteristic and can be employed to automatically control the drive. They have flexible control characteristic and it can be employed to automatically drive the automatically control the drive. Because of the advantages, the mechanical energy already available from a non-electrical prime mover is sometimes first converted into electric energy by a generator and back to the mechanical energy of electrical motor. Now the electrical link thus provides between the non-electrical prime mover and the load impact to the drive flexible control characteristic. At present, the AC motor is used within a variable speed drives because of the semiconductor converter development. They have a flexible managed characteristic due to utilization of electric braking. The previously the motors like synchronous as well as induction were used within stable speed drives. The changeable speed drives utilizes a DC motor. For example, the diesel locomotive produces the diesel energy by the help of diesel engine. The mechanical energy is converted into electrical energy by the help of generator and the electrical energy is used for driving the other locomotive. The electrical link thus provide between the non-electrical prime mover and the load impact to the drive flexible control characteristic. Now there are some disadvantages of electrical drives. The power failure completely disabled the whole of the system The application of the drive is limited because it cannot use in a place where the power supply is not available. It can cause a noise pollution and the initial cost of the system is high. There are some more disadvantages. This drive cannot be used where the power supply is not possible. We have seen it already. By using this drive, noise pollution can occur. The drive output power which is obtained is low. The dynamic response of this drive is poor. The primary price of the system is inexpensive and the power breakdown totally stop the entire system. During the breakdown of the conductor or the short circuit, system may get damaged due to which several problems occur. The application of the drive is limited because it cannot use in a place where the power supply is not possible. Now there are some applications of electrical drives. These are used in domestic and industrial applications like electric motor, factories, textile mill, fan, transportation system, pump, robot, etc. These drives are used for the electric traction to transport the material from one place to another. Electric tractions are buses, electric trains, trolleys and vehicles that are power driven with solar. These drives are used for the electric traction to transport material from one place to another. The electric traction are buses. These are used in spinning the machines, conveyor system, extruders, draw lines, blower in yarn, crane and unwinding. These drives can be used like main movers for the engine like petrol, diesel, turbines like gas, steam, motor like hydraulics and electric. It is used in large number of industrial and domestic applications like transportation system, paper machine, fan, machine tools, etc. The main application of this drive is the electric traction, which means the transportation of the material from one location to another location. These are extensively used in huge number of domestic as well as industrial application. These are used as the main movers for the petrol and diesel engine. So, the system which is used for controlling the motion is named as the drives. Sometimes motors are also used as a drive. Depending on its application, both the drives like AC and DC are used in industries, and these drives are economical, pollution free, give a long life and easily movable from one location to another. Now the factors which are used for the selection of the electric motors in electric vehicles. Each motor has its characteristic and advantage. There are specific requirements of electric vehicles motors such as high power density, fast torque response, high efficiency over full speed and torque range, high robustness and good reliability for many vehicles operating conditions and at reasonable cost. In 1993, all the electric vehicles were derived using a direct current, that is DC variable drives. DC drives have a commutator due to which a maintenance cost is less as compared to the conventional drives. But we all know that the DC motor is used for the low power level up to 4 kW needed support and had a shorter lifetime. However, it is suitable for a small power applications such as electric wheelchair, microcar, etc. So, with the advent of the alternating current, that is AC drives, which are more advantageous, we move towards the AC motor. As we know that the motor is the most essential component of EV, so it is essential to select a suitable type of motor with a suitable rating. Induction motor used as a commutator motor type of EV because of high reliability and free from maintenance. So this is the diagram which shows the factors. There are induction motor, there are motor types: induction motor, synchronous motor, PM, brushless motor, switched reluctance motor. In induction motor there are again two types: squirrel cage and wound rotor. In synchronous there are two types: wounded rotor, PM motor, and reluctance. In PM motor rotor there are again two types: surface mounted and interior mounted. So it is very popular AC motor and has a variable speed drive applications such as air conditioning, elevator or escalator, and many higher power EVs for more than that of 5 kilowatt energy. Classically, the induction motor and synchronous motor are used to feed a sinusoidal supply and produces a constant instantaneous torque without using an electronic controller, immediately replacing a field winding with a permanent magnet. Then the synchronous motor will turn into a permanent magnet synchronous motor. The permanent magnet rotor has been selected by its high kilowatt rating and current ratings, providing superior torque speed combined with lightweight commercial availability and compact dimension. PM rotor is further classified into two types: surface mounted and interior mounted. The surface mounted has the magnets outside and motor, whereas the interior mounted has a magnet inside the magnetic structure of the rotor. Preference should be given to the internal model because of its high operating speed. Now the modern motor, that is PM brushless motor, is used to overcome the IM or the EVs because of its advantage like increasing the speed range and the improved efficiency. As in this there is no rotor, due to which rotor copper losses are absent. However, motor efficiency is inherently higher and its acceleration is also improved. The switched reluctance motor is a synchronous device that operate on inverter driven square wave unipolar current. It is a variable reluctance machine and it has a fault tolerance capability because of the absence of PM, and its reliability also improves. Some researchers used an SR motor, that is switched reluctance motor, in vehicle traction that could make the system cheaper and also improves the performance of the system. Several other researchers and companies also in the process of using SR motor in the electric propulsion system. Thank you.